If you have played Marvel Rivals or seen the latest Captain America movie, you already know this shield. There are many differences between the MCU and the Marvel Rivals version of the shield. While the MCU one is classic and simple, the static version, not my style. That is why I went with the Marvel Rivals version, because it expands and has a reactive lighting. Let's get started. The one from Marvel Rivals has more of a mechanical look. It has some kind of glowing energy flowing through it, and that energy shield at the borders can expand and retract to cover a bigger area. That means two things: electronics for all of the lighting, which is not only located at the edges, but also at the center. And mechanics for the expansion effect of all of the surrounding pieces. So pretty sure Steve had some help from either Wakanda or Tony Stark. Now, here's the 3D model for the project, where there are three main areas for the LEDs. The first one is to illuminate the edges of the star and the blue disc. There will be another ring of LEDs turning areas of this white ring into blue. And finally, another ring of LEDs aiming towards the surrounding pieces to simulate the energy we talked about before. For the expanding mechanism, I kept it as simple as possible. This center disc will turn to make this ball bearing slide, turning rotation into linear motion. That is how we will move from this to this. I know this was kind of a lot, but don't worry, you will see this in action soon. First, let's print the shield. Yeah, definitely should have used 3 supports. They say patience is a virtue. I wouldn't know, I have power tools. Every piece now is sanded and primed. Now to make all of this look metal, I am going to use this base for the red parts, and then I'm going to use this metallic base for the blue parts. The rest is going to have this metallic stainless steel finish, and all of it is going to be covered in this satin finish. Of course, I tested all of this, and these are the colors we are going to end up with, which are actually perfect. And thus, all of our pieces are ready. And at the end, I paid the price for my lack of patience. I broke one of these tiny little legs from the star, one of the tops of the surrounding pieces, and the biggest ones, these corners. Not a big deal since these areas are going to be under the other pieces, so it's going to end up looking like this. These areas were mainly made for positioning and to cover the gaps between different components. Knowing this is the shield we want to achieve, most of the pieces are pretty intuitive, others not that much. But don't worry, I will explain all of this in the assembly. I will say this right away, over 100 screws. That is what we will need to put all of this together. This is the box where I put my screws, by the way. Why don't you just glue everything into place? Because I will need to wait for everything to dry, and if something doesn't fit perfectly, I will need to separate, and I don't want to risk breaking any of these, besides the parts I already broke. Yeah, that makes sense. I mean, not everything has to be joined with screws, only the parts that are going to be under some stress, like for example, the main structure, the expanding mechanism, the back cover, and the pieces for holding the shield. For the rest of the parts, we can go with glue. Agreed. So, electronics? Yes, electronics. You need help with that? No, I'm good. We all know that every high-tech shield needs some flashy lights and sensors. As always, an Arduino Nano will help to control every part. For lighting, I picked RGB LEDs, since the illumination will need to change colors now and then. With 213 of these, I went with an 11.1 volts and 4400 milliamps battery. Also, I always get the ones that have already a female plug. It's just a lot more practical. Yes, I know 2000. It is going to be 213, but it's going to look amazing. Now we can jump from this to this. Took a couple of days and a ton of work, but it is ready. So what do we have here? First, the male plug that is going to connect to the battery. Then the switch. This is going to allow the power from the battery to go into the circuit. Because this is not soldered yet, which is going to happen at the end of the assembly, if I just plug the battery to this cable, everything is going to turn on. Here we have our Arduino with some resistors, two buck boost voltage regulators to adapt the 11 volts from the battery to the 9 volts of the Arduino, which usually works in a range, and the other one to 5 volts for the LEDs. Then we have a micro interrupter, which is this guy, and best of all, two touch sensors. Finally, the LEDs are going to place in sections, that is why you see them separated by cables. Now I'm going to show you how this works. First, we connect everything to the battery, and most of the LEDs are going to turn on. There are some of them that are off. This microinterrupter tells the Arduino when the shield is fully expanded, so the rest of the lights can turn on. In the meantime, I'm going to keep it pressed so I can show you what the touch sensors do. One of them is going to be in momentary mode. This is going to be in the center of the star of the shield, right here. This will sense impact or taps, so the rest of the lights react in a wave motion from the center of the star to the surroundings. However, these three are always yellow. Well, that's because after I saw Captain America Brave New World, I really love the purple effect from the vibranium. So this one is going to allow us to change to which color the shield is going to turn. So yeah, this will let me know in which mode it's going to be. I am usually active in the comments, so if you have a question about it, drop it down below. Also let me know if you would like me to make a video about voltage, amps, power. I think that one will also be pretty cool. Okay, now let's assemble electronics and mechanics. Assemble! Let's make some space first. Perfect. The white roundish part will hold the base of all of the sliding pieces. The ones I showed you before, remember? With that ready, we can assemble the whole front of the shield, which is something I'm really looking forward to. See, all of these holes here are not just for holding the ball bearings, but also for attachment to the red parts. This part of the assembly took longer than expected. However, I think it's looking pretty good. I added glue to join the corners since there's a little bit of an offset, but that is to be expected in every build. In any case, all of this is screwed together, so this structure is going to keep everything in place. After the glue has finished drying, I can start placing the surrounding areas and then move to the electronics as well as placing the LEDs. The surrounding pieces are in place and all of the gaps that you can still see are going to be covered with these two pieces. Here is something I didn't think through. The star with the electronics is installed from the front. However, since the back is covered with the red and white parts, I had to position the LEDs with all of that in the way. There's honestly a lot of space to add super glue and put the lights in their place. It just wasn't ideal. By the way, can we talk about how cool this is already looking? I mean, that at least deserves a like. Come on. Anyways, after that, I went ahead and installed the rest of the LEDs, added clamps, and waited for the glue to dry. LEDs are in place. However, you can see the outer rings has some kind of irregular shape, and that happens because LEDs are on a straight line, but they are placed in an inclined curve. Was it planned to be like this? Of course not. I figured there would be a little bit of this effect, not that much, but we need light variation, so I will take that as a win. And this is how our shield is currently looking. I think it's looking pretty good. And the fact that we already glue all of the pieces surrounding the main structure, that makes all of the surroundings a lot stronger together. Now to the glowing edge of the shield. Since this part needs to glow, it has to remain a little bit translucent rather than colored. But how do I make it strong and translucent at the same time? Well, I got help from JLC 3DP to achieve just that. I designed 8 pieces with a pattern similar to Captain America's shield. Then I uploaded them to the website, and just a few days later, here they are. Since these pieces will expand and retract, they need to be tough. So I went with the 8001 resin, a strong and durable option. And of course, I picked the translucent version without surface finish. The price for each of these was $9.9 plus shipping. By the way, this print uses SLA technology, short for stereolithography. You can see how the shapes I added in the resin distort light just enough to make them visible, and that is exactly what I need to recreate the effect from Marvel Rivals. I think I'm going to sand this to get even closer to the desired result. If you want to know more about this or any other material that JLC 3DP offers, check out the link in the description. They have tons to experiment with. These are the reason these lights are inclined, so the light can bounce back even better. The next step is to add this and finish the expanding mechanism. In the meantime, I will leave this beauty on the side for now. The resin part, which is the same design printed 8 times, is going to be assembled with the extending pieces this way. And 3 screws will keep them in place, keeping the mechanical look we are trying to achieve. Now here's the thing. In the non-expanding mode, if I place them together like this, when they do expand, there's going to be a small gap between them, and we can't have that. That is why I designed the mechanism for them to have a small overlap. So when they do extend, they're going to look like this. And that means there is a small offset between them. Well, the easiest way to do that is to design these 2 pieces a little bit different. You see that the one at the left is kind of straight, while the red one is a little bit shifted to the left. So there will be one red and one white all around the shield, except for that one. That is a little bit different. We'll talk about that one later. It does have a very special purpose. Expanding mechanisms are ready, and we can finally put them in the shield. First, I am placing the 4 corners that will have the resin sides closer to the front of the shield, then the ones that will be further away. These parts will move smoothly thanks to 4 ball bearings placed on each of these bases. The white web-looking piece is the one we will rotate with another ball bearing in the center, so the resin sides move in and out. Now I need to add more ball bearings connecting the rotating center to the red and white sliding parts. And with that, we finish this awesome mechanism that moves smoothly and with no issues at all. I really think watching this part work is kind of hypnotizing. Do you think so too, or is it just me? After that, we can finally install the microinterrupter. Magic is ready, meaning pretty much all of the electronics and mechanics are in place, and I really love how all of the resin sides expand and contract without any hiccups. In the left hand, you can see how this specific piece is the one that activates the microinterrupter every time it opens. And when it is fully retracted, it deactivates it. And this is how it is looking in the front. It does look pretty awesome. With the resin sides, the look at the front is already complete, which takes us to the question, how am I going to cover all of the backside? How am I also going to hold the shield? And if all of this is going to be covered, how am I supposed to manipulate the mechanism? Well, let's start with the last one. Step 1. Grab this suspicious looking blue piece. Step 2. Grab a ball bearing and place it in this hole very gently. Step 3. Connect the rotating piece and the blue piece with an extension spring. Finally, screw them both together. But what exactly is this? Well, it will be some kind of a handle we will use later. For the back cover, I will be using these 4 pieces, and you can see in the back side I added an arrow, which should always point upwards to indicate the direction of the top of the shield. This is just something to make the installation easier because I'm really clumsy and sometimes I get it wrong, even when pieces are clearly incorrectly placed. The top cover is the one that is going to house the second touch sensor. as well as the last three LEDs, which are going to indicate the color of the effect. We can finally solder the on and off switch, which is going to be placed at the left cover. And in this one, I will also place the plug for the battery. Finally, the bottom cover is the one that is going to hold the battery thanks to these flexible attachment points. This middle part is going to be covered as well, but that is going to be at the end. Right now you can realize there's still a lot of holes without any screws. And that's because I'm going to place these two pieces, which are the holders. Actually, I can put them right away so you can see where they go. Anyway, this is pretty straightforward. This is where I'm going to put my hand. However, this is the one that I want to talk about. This one has two holes and it's kind of obvious that I'm going to place a material for my forearm. These are cable sleeves. These are not supposed to be used in this case. However, this is the one I have right now, so this is the one I'm going to use. And this is not very scratchy or anything, so should be fine. Now for the pieces I'm going to place in the back of the mechanism, there will be one plastic one and a circle of copy paper I'm going to place on the back side. This is so even though everything is covered, I can still kind of see a little bit of the light on the inside and the movement of the mechanism. With the back cover ready, also both of the holders, we can finally pick up the shield from my dog's bed, which, let's face it, looks like the perfect place for it. There we go. Let's finish this beauty. Two months after this idea got into my head, we have our Captain America shield. Look at this thing. Oh my god. I love that the size is perfect, also looks pretty good on the vertical or horizontal position, as well as the mechanical look all of the screws give on the back. The mechanism is so easy to control with only 2 fingers. Everything expands. Now all of that is pretty awesome. Let's test the shield with the light effects. Alright, with the shield expanded, we can test the impact effect. One touch at the start and we get our ripple energy flowing outwards. With the back sensor, we change to Wakanda mode to get the same effect, but with vibranium purple. You can clearly see from the back when the lights in the middle turn off, meaning the lights of this white circle. Okay, this is pretty heavy. The part that costs the most is not actually lifting it, it's kind of turning it this way, otherwise it will just try to rest in the horizontal position. So the biggest effort by far is trying to do this all of the time. Holding it like this is very simple. I can do this all day, but I cannot hold it like this all of the time. But is it worth it, even though my hand gets all shaky? Absolutely. I think we really achieved the design loyal to the game while making it functional. The shield has to be on my wall. I'm just still wondering where and how because of the handle, but I will figure that out later. Right now, I'm super happy with this build. Remember that everything you need for building your own Captain America shield is on the Patreon shop. STLs, list of parts, code, assembly instructions, everything. So head over there so you can start printing and building your own. Do let me know what you think, if you would make some changes or add something else. I'm really curious about your thoughts. But overall, I'm really happy with this build. If you are too, give this video a like and subscribe for more projects like this. If you would like to see more, here are woven cloths that extend and retract. or deployable arm blades from Spider-Man 2099. Thank you very much for watching, and I will see you in the next video.